All right, let's go ahead and open up the page 119.
I'm not a nerd, but so what?
All right, so yesterday we kind of reviewed the factoring techniques that we discussed at the beginning of the year, and we're going to have to be really good with these factoring techniques because we're going to be using them this whole unit. So we're going to see a little bit more with factoring today, but specifically how factoring relates, relates a function to its graph. So we're going to try to see that connection going on here. So on page 119, the directions at the top say factor each of the polynomials, and we should be good with that, but we're going to analyze factors versus graph and see that connection. So taking a look at our first function there, how might you want to factor that function based off of what we talked about yesterday? Yeah?
We could start off by dividing 3x.
Okay. GCF. Let's always try to take something out first. Maybe it'll make the variables or numbers kind of easier to work with. So all those terms have a 3x in common. So we'd be left with an x squared plus 4x plus 4. So GCF, always try that first. But you got to ask yourself, okay, can you keep going? Can you use another technique? You see another one? Yeah. What do you mean by square root? You are right that we can keep going, but I'm not sure about...
Like they're both all perfect.
Okay, so x squared, 4x, and 4 are all perfect squares, okay? So yesterday we talked about a difference of perfect squares if we were just subtracting two things, but in this case we have 3. So they are perfect squares, but it's not necessarily a difference of perfect squares. Let's see, we had GCF, we had divide and slide, we had grouping, we had difference of squares, difference of cubes, yeah.
I simplified it to x plus 2 on both sides.
For both of them? Okay. So I know we haven't really discussed this one yesterday, but this is kind of the more typical factoring technique. I call it I am factoring. Maybe that sounds familiar. If your A term is 1, like this one is, you can think about what multiplies to the last term but adds to the middle. So two numbers that multiply to 4 but also add to 4, those would be 2 and 2. So you have two factors, x plus 2, x plus 2. Okay? You could write that technically as x plus 2 squared, right? Because you're multiplying the same thing. You can write it as a power of 2 because you have 2 of them. Okay? So let's take a look at perhaps how these factors are related to the graph. Do you remember the graphical connection? We briefly talked about this at the beginning of the year. If these factors equaled a specific number, what did the solutions for x represent? Go ahead, Hannah. The x-intercepts. Okay, so if these factors equal 0, which is typically what we want the equation to be when we're factoring, if we look at the first factor of 3x, what would the x value have to be to get that factor to be 0? 3 times what number would give you 0? Yeah. 3 times 1/3 would give you 1.
Oh, sorry,
0. Okay, so this x solution would be 0. And then when you look at the other factor of x plus 2, what would that x have to be to get you to be 0? What number plus 2 would give you 0? Yeah. Negative 2. Okay, so take a look at the graph. Notice how on the x-axis we cross at 0, or the origin, and we also, not necessarily cross, but we touch the x-axis at negative 2. Okay, so there's a graphical connection between the factors that we can develop and the graph that the function creates, okay, specifically in terms of the x-intercepts. There's another connection, though, between the graph and the kind of standard form equation at the top when it's not factored, like no parentheses going on, all the terms are listed in order. What's the y-intercept of this graph? Where does it cross the y-axis? Can you identify that location? Let's see, the y-axis is right in the middle. Where does that kind of roller coaster polynomial graph cross it? Go ahead, Marie. 0, okay? What is the constant term of the equation? Okay, and I'm referencing specifically the standard form equation. So constant term just means no variable attached to it. Okay, you're just a solid number. Do we have just a solid number listed in that standard form equation? No, so we could probably say it's 0 because we don't have one. All right, so maybe there's another connection there that you might start to identify. Let's take a look at the next one. Okay, so they give us a standard form equation. The terms are written in order. Let's go ahead and try to factor it. Maybe we can determine where those x-intercepts are. We already know where they are based off the graph, but let's see if we can figure it out by hand. Okay, how might you want to factor that one? Can we pull anything out? Is there a GCF? No. Okay, it's not a difference of squares. It's not a difference of cubes. The a term is 1. Okay, so maybe we can think about I am factoring. What are two numbers that multiply to 4 but add to -5? Yeah. -4 and a -1. Okay. Now we kind of got to be careful with this because notice how the standard form equation we're starting with is an x to the 4th power. Okay, it's quartic. So if we have 4 x's, we need to evenly divide up those 4 x's between the two factors. So each factor would get 2 x's. We can write x squared. So we completed the I am factoring, but you got to ask yourself, can you keep going? Okay, are there other factoring techniques? Do you guys notice anything else we could possibly do? Good, Rebecca? Yeah.
You can break that up even further for difference of squares.
All right, they're both difference of squares, right? So if we look at the first factor, we would have an x plus 2, x minus 2. And then the second factor, we'd have x plus 1, x minus 1. So since we factored completely, if we were to set these factors equal to 0, then the solutions for x would represent those x-intercepts. So if we have 4 factors, we're going to have 4 x solutions. Looks like we'll have -2 from the first factor, and then +2 from the second, and then -1 from the third, and +1 from the fourth. So graphically speaking, these should represent the x-intercepts, and if you take a look at the graph, notice how we either cross or touch the x-axis at those spots. So it seems like our factoring was correct. We're getting the values that we should. Okay. What about the y-intercept of this polynomial, this roller coaster type graph? Yeah, 4, okay. So then what is the constant term from the standard form equation? Do we have a value in there that doesn't have a variable attached to it? Do you see how that's the 4 on the end? Okay. Let's go ahead and try the last one. Factoring, what do you guys want to try? What do you think, Marie? Grouping. We have 4 terms, okay? If you look at it real quickly, you could probably think GCF isn't going to work because you can't really take anything out of a 2 and a 5. So after that, hopefully you notice that there are 4 terms, and that should kind of be a signal or a light bulb that goes off, kind of signifying grouping, because you can group 2 and 2. So from yesterday, okay, what can we take out of the first group? GCF from the first 2 terms? Yeah. X squared, and you're left with 2x plus 5. Is there anything you can take out of the second group so you're left with another 2x plus 5? Yeah. A negative 1, we'll say, okay? So notice how the 2x plus 5's match. That's perfect. That's what we need to happen. So our 2 factors are x squared minus 1, and then 2x plus 5. So we're done with grouping, but ask yourself, can we keep going? There was, I think a few years ago, before you guys were, I think you guys were still in the middle school maybe, they had a Toy Story group coming through, and they didn't necessarily do what they're doing out there, but in between the periods, if the toy people saw Andy walking through the hallways, they would just like freeze. And it was kind of hectic because in between periods, they're trying to exchange classes, right? But if people are frozen in the hallway, it's kind of hard. But it was really, really neat to see that. But they're taking it to the extreme this year. All right, can we keep going? Yeah. There's a what? The first one, we're subtracting, right? Difference of squares. So we got x plus 1, x minus 1, and then the 2x plus 5. Okay, so those are the factors. If we were to set them equal to 0, we could figure out the solutions for x. Looks like negative 1, positive 1, and what about the last one? Yeah? Negative 5 over 2. Good. Okay, so graphically speaking, notice how we cross or touch a positive 1, negative 1, and then negative 5 over 2 is the same as negative 2.5, so looks like that's showing up too. All right, what about the y-intercept of that graph? Where does it cross the y-axis? Yeah? Negative 5, okay, and what's the constant term from the standard form equation? Yeah? Negative 5. All right, so it looks like we have kind of 2 connections here that are important. We first have the connection that the factors of a polynomial, when set equal to 0 specifically, give us the x-intercepts. But we also have another graphical connection. Okay, the y-intercept of the graph is found or represented by the constant term in the standard form equation. So we're just going to jot down those 2 ideas at the bottom of the page. So we'll say when set equal to 0, the factors give the x-intercepts of the graph. And then the other connection we have was the constant term of the standard form equation is the y-intercept, okay, of the graph. So those are 2 concepts that we're going to use throughout this unit. Let's make sure that they kind of make sense to us through those 2 examples. But we're going to continue to look at factoring and graphs and some other connections that those have. Are we doing okay so far? We're good with factoring? It's going to be important this unit. All right. Let's go ahead and take a look at page 123. So we're going to transition to the next section, but it's still going to involve factoring and it's still going to involve graphs. Okay, we're just going to relate factoring in graphs to the idea that we talked about in the first unit where we were looking at above x-axis, below x-axis, all that good stuff. So we're kind of making all these connections together. So the graph of this polynomial is pictured below. That's right here. They want us to factor f of x and use the factors to find the zeros. Zeros is just another word meaning x-intercept. Okay, so this is basically what we did in those last three examples. We're going to try to factor the polynomial, set it equal to 0, and then those solutions represent those x-intercepts. So taking a look at this polynomial, how might you want to factor it? Yeah?
You can start with the
GCF, let's take out an x, yep. All right, and then ask yourself, can you keep going? Yeah? You could. Okay, so our a value is 1. Okay, 1 times -6 would give you -6. So you got to think about two numbers that multiply to -6 but add to 1. Yeah? +3 and -2, yep. Technically the divide and slide, you would then have to divide by 1, but that's not really going to change anything. Okay? So that's as far as we can go for those factorings. Did you find Andy?
Yeah, we dropped in front of your door.
You dropped? All right, so if those are the factors that we have, let's set them equal to 0, and then we can figure out our x-intercepts, or in this case, the zeros, whatever word you want to use. Okay, so we have 3 x's showing up in the factors, which means we should have 3 solutions. What value or solution are we going to get from the first x? Yeah. Say it again. 0, good. Okay, and then the next factor looks like we would have -3, and the last factor we would have 2. Okay, that should graphically make sense because if you look at the picture, that's where we have those x-intercepts, where you're touching or crossing the x-axis. Perfect. All right. Let's also take a look at the graph and maybe we can identify some of these above x-axis, below x-axis connections. So the first one is asking us when is the graph, or the y values, remember f of x is the same thing as y, where does the graph have y values of 0? Yeah. Yep, those are the x-intercepts that we just found. Okay, that's where we have a y value of 0, aka the x-axis. What about number 2? Where are the y values greater than 0, meaning positive? Yeah. Uh-huh. 2 to infinity, yep. Okay, so if we want y values that are positive, that means the graph is above the x-axis. What about number 3? Y values that are negative, meaning below the x-axis. Yeah, Marie? Okay. And then 0 to 2. Okay. 4 and 5 are kind of similar, but they're slightly different. Now we have that equal bar underneath it. So in this case, we want y values that are above the x-axis, meaning positive, or equal to 0, meaning on the x-axis. So these intervals should look very similar, but instead of having to skip over those x-intercepts using parentheses, now we can actually include them because we can touch the x-axis. So this one's going to look similar to the number 2, just with brackets on the x-intercepts instead of parentheses. Does that make sense? Because you can touch the x-axis at those spots now. And then for number 5, that should look very similar to number 3, but now we can include those x-intercepts. So we're going to use brackets on those values. Okay, so I don't think that's anything new to us. We've been doing above x-axis, below x-axis for a while, okay? But all of these intervals are based off of a graph that has been provided to us, okay? What if we don't have a graph? How can we still determine where the graph is above the x-axis or below the x-axis without physically having that picture? So that's where we're going to transition. Okay, the last unit we always had a picture. This one we don't. So we're going to see how can we still conclude or develop those intervals, okay, without necessarily having the graph available to us. So what we're going to do in the little table below is create kind of a number line that we did very similar to the absolute value graphs. Remember doing that? It's going to work very, very similar to that. So I hope it kind of sinks in. In this case, we're going to try to factor, okay, just like we did at the top. We want to figure out where is the graph on the x-axis, and then maybe from there we can figure out, well, where is it above, where is it below? Okay, so we're going to start off with the points that we know for sure are on the x-axis, which comes from factoring. So this is already the example that we did, okay, at the top. We said we took out an x, and we could factor further. We had an x plus 3 and an x minus 2. Okay. We're going to find the zeros, okay, or the x-intercepts based off of those factors. Again, we already did that. 0, -3, and 2. And those are going to be the special values that we label on this number line. Remember how we had those special values or the changing points for the absolute value graphs? So we're going to draw our number line, and then in order, we'll list those x-intercepts. Okay? So we know that these are the spots where the graph is on the x-axis. We got to kind of test or figure out what's the graph doing in between these values. Okay, is it above the x-axis or is it below the x-axis? Okay, so we'll label these spots as on the x-axis. What did we do from here in terms of the absolute value number lines? Do you kind of remember? Yeah. There we go. We're going to pick a number in between the intervals. So from -∞ to -3, pick any number you want. Something easy. Yeah? -4. Okay. So we're going to take -4 and we're going to plug it into the factors that we found from the polynomial. So if you plug in -4 into x, okay, that's a negative value. Remember, for absolute values, we were only concerned about the sign. We didn't really care what the number was. Same thing going on here. If you were to plug in -4 into the next factor, -4 plus 3, that would give you a negative value. And if you were to plug in -4 into the last factor, -4 minus 2, that's negative as well. So if all three of those factors are negative, and you are multiplying those factors together, what's your overall sign? Negative times a negative times a negative? You're negative. Okay, so we'll label that in this little interval, okay, from -∞ to -3, our graph is negative, meaning below the x-axis. Okay, pick a number between -3 and 0. Yes? -2. All right, so -2 into the first factor is negative. -2 into the next factor is actually positive. And then -2 into the last factor, negative again. Negative times positive times negative? Yeah? Positive. Okay, so on that interval, our graph is positive, meaning above the x-axis. Okay, notice how we don't have a graph of it. I know we do at the top, but let's pretend that we didn't. Notice how we're starting to determine where the graph is located, either above or below the x-axis. Pick a number between 0 and 2. Good, Marie? 1. Okay, 1 into the first factor would be positive. 1 into the second factor is positive as well. 1 into the third factor, though, is negative. Positive times negative. Looks like we got negative. Alright, in our last interval, pick anything you want between 2 and infinity. Yeah. 4, okay. 4 into the first factor is positive. 4 into the next factor, positive. 4 into the last factor, positive. Positive times positive, all positive. Okay, so with this number line, we're going to analyze what we're trying to figure out. Okay, are we above the x-axis or below the x-axis? And then we're going to identify those specific intervals. So in the last box, it says refer to the original inequality sign. Okay, so we want this polynomial, that function or graph, to be greater than or equal to 0. So that inequality, greater than or equal to 0, what are we trying to analyze or figure out based off the graph? Are we above the x-axis, below the x-axis? Do we happen to be on the x-axis? What is that symbolizing? Yeah. On or above 0. Okay, so that inequality means the graph is on or above 0, or aka the x-axis. Okay, so if that's what we're trying to identify, that's what we need to then find based off of our number line. So take a look at your analysis there. Where are we either on the x-axis or above the x-axis? What do you think, Marie? -3 to 0. Okay, we said we were positive, meaning above the x-axis. And we are on the x-axis at -3 and 0. So we can include those as brackets. Was there another interval based off our number line? Yeah? 2 to infinity. We said our graph was positive, meaning above the x-axis, and we're on the x-axis at 2, so we can include that with a bracket as well. Isn't that the same interval that we got from the table kind of in the middle of the page? Okay, so in the middle of the page, we specifically were using the graph to help us determine those intervals, but notice how when we use that number line chart, we don't necessarily need the graph anymore. So we are transitioning from kind of an easier concept that we're familiar with to something a little bit more difficult. We have less information to go off of, but that doesn't mean we still can't figure out where we're above or below or on the x-axis. Okay, let's go ahead and check out another one. Okay, the graph of the function, that cubic function is below. Let's go ahead and factor it to figure out the zeros, okay, those x-intercepts. Any factoring technique you guys want to try? Yeah. Grouping, we have 4 terms. Hopefully that was the little light bulb. Okay, so we'll group the first 2, group the last 2. What GCF can you remove from the first group? Go, Marie? Okay, so we're left with an x plus 3. Okay. What can we remove from the second group? Yeah, a 2. Okay, so we get the same x plus 3, which is perfect. Our 2 factors, let's see, we got negative x squared plus 2 and then x plus 3. So we're done with grouping. You gotta ask yourself, can we go any further? Yeah? What about it? You mean like a difference of squares type thing? Not quite, okay, because this 2 is not a perfect square. If you, like 1, 4, 9, those are your perfect squares. So this is not necessarily a difference of perfect squares, even though this one is a perfect square. I don't think we can go much further, okay? So if we were to set this equal to 0, we got to figure out what the x solutions are, meaning the x-intercepts of the graph. So I'm thinking the last factor is pretty simple for us. That would be -3. Okay, but the first factor might be a little bit trickier for us to think about. So maybe off to the side here, we'll try to solve, okay, what would make that factor 0. If we subtract the 2, divide the negative, how do you get rid of a squared? Square root. Okay, and whenever you take the square root of both sides, you need that plus or minus in there. Okay, you're developing 2 solutions. So it looks like we have 3 x-intercepts. One of them's at -3, so if we check out the graph, that seems to be there. And then we have 2 other ones. We have a positive square root of 2 and a negative square root of 2. This is roughly 1.414, I think. And notice how that kind of makes sense based off the graph that they gave us. Okay, so we found all those x-intercepts. Now, since they gave us a graph, they were nice to us, let's go ahead and identify where this graph is above the x-axis, below the x-axis, possibly on the x-axis, and then we'll use that table to help us maybe check our work when we go through another number line example. Okay, so this specific graph equals 0, aka on the x-axis at those zeros we found up top. We said -3 and then either plus or minus the square root of 2. What about when the y values are greater than 0? Meaning above the x-axis. Can we fill in those intervals? Yeah, go ahead. Okay. Okay. Uh-huh. There we go. Looks good. What about 3, where the y values are less than 0? Where's that graph below the x-axis? You want to keep going, Marie? Go ahead. Okay. Square root of 2 to infinity, yep. Alright. The last 2 are very similar to the ones we just did, but notice how it includes 0 now because we have that bar there. So we can physically include those x-intercepts that we skipped over from the previous intervals. So if we want to be above the x-axis or on it, we can bracket 3 and then bracket those square root of 2's. And then for 5, we can bracket the -3 and negative square root of 2 and then the positive square root of 2. Okay, so we're basically taking the previous intervals we found, but just including those x-intercepts because we have that bar. Okay. So we know that these intervals are correct based off the graph that we have. Let's see if we can maybe figure out one of these intervals using the sign or the sign number line to help us. So let's say we didn't have the graph, okay? We would factor the polynomial, we would set it equal to 0, try to figure out those x-intercepts. Fortunately for us, we already did that. Okay, we had the x solutions of -3, negative square root of 2, and positive square root of 2. So those are going to be the special numbers that we kind of label on that number line. Make sure we put them in order. Maybe I'll write down the factors we had too, because we're eventually going to plug in numbers into them. All right, so pick any number you want between -infinity and -3. Yeah. -4. Okay, so if you plugged in -4 into your first factor, -4 squared would change to a positive 16, but the negative out front changes it back to a -16, plus 2 would still be negative. So our first factor is negative. If you plug in negative 4 into the second factor, that one's negative as well. So a negative times a negative would actually end up giving you a positive value. Go ahead and pick something between negative 3 and negative square root of 2. Remember, this is like negative 1.414. Yeah? Negative 2, okay? So negative 2 into your first factor would end up being negative. Negative 2 into your second factor ends up being positive. Multiplied together, your overall negative. What about something in between negative square root of 2 and positive square root of 2? Really easy number, yeah. 0. 0 into your first factor, positive. 0 into your second factor, positive. Multiplied together, positive. And then our last section, square root of 2 to infinity. Anything really there? Yeah? 2, okay. 2 into your first factor would be negative. 2 into your second factor would be positive. Multiplied together, we get negative. All right, so let's go ahead and reference the question at hand, okay? We want the polynomial or graph to be less than 0. So graphically speaking, what is that symbolizing? What should we be looking for? Less than 0 means what? Yeah? All right, means the graph is below the x-axis. Hannah, is that what you were going to say too? Perfect. Okay, so take a look at your number line. Okay, we just want to be below the x-axis, not on it, okay, because we don't have that bar there. So looking at your number line, it looks like we're negative, aka below, from negative 3 to negative square root of 2. We cannot include those values because those are on the x-axis. We just want to be below. And it looks like we have another interval from square root of 2 to infinity. Does that match the interval we had from the chart above when we had the graph? Right? Okay, so this sign chart process, or not chart, but this sign kind of number line process that we're familiar with from those absolute value questions is going to help us figure out where a polynomial graph is above or below the x-axis. Without necessarily knowing what the graph looks like or having the picture, we can still analyze the function. And that's all through factoring. Notice how you have to factor first to get those special x-intercept spots. Are we doing okay with that line chart, that number line? All right, we'll stop there for today. We'll do a few more examples tomorrow. Okay, notice how the next page is very similar, but we're going to step it up and try to do one without a graph to check our work. We'll try to see how we do there.